Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring functions. We'll start with a definition, and then we'll discuss how to represent functions in different ways, such as verbal descriptions, equations, tables, graphs, ordered pairs, and mappings. We'll finish up by learning how to use the vertical line test to determine whether a graphical relationship is a function. Some of the concepts you might have been exposed to in previous grades, but today will serve as a good review for most of you. If there's any time you need to pause the video because you need extra time to write something down, or you want to review the concept, just pause and start again when you're ready. All right, let's begin with the definition. A function is a clearly defined rule that converts an input from one set of numbers known as the domain into exactly one output from another set of numbers known as the range. Now, for a relationship to be a function, the value of x cannot repeat. And we'll talk about that more in just a minute, okay? Now, as I said, functions can be represented many different ways. Verbal descriptions, equations, graphs, tables, ordered pairs, and mappings. And in the first few examples on the front page, we'll be looking at all the different ways we can represent functions. So let's start with number one, example one. A function is defined by a verbal rule. Divide the input by 2, and then add 3 to obtain the output. The domain or input set for this function is 0, 2, 4, 6, 8, and 10. Represent this function as a table and a graph, and then state the range. So what I want to do here is highlight my knowns and my unknowns. So let's see what we know. We've been given a verbal description. Divide the input by 2 and then add 3. And we've been also given the domain for the function is 0, 2, 4, 6, 8, 10. In green, I'm going to highlight what the question is asking us to do. So the question is asking us to represent this function as a table and a graph, and then state the range of the function. All right, so the first thing I know is they've given me the domain. So that will be easy to fill in my table here. 0, 2, 4, 6, 8, and 10. Because this is your domain, it's also called your input. It's your input values, all right? Now, your output is your range, okay? So whenever we have an input, we're going to use our rule that they gave us to find the output. So the rule was to take the input, divide it by 2, and add 3. So if I took my first input value, 0, divided it by 2, and then added 3, what would the output be? So 0 divided by 2 is 0, and 0 plus, add 3. 0 plus 3 is 3. So my first output value is 3. All right, let me take my second input, which is 2, divide it by 2, and add 3. So 2 divided by 2 is 1, and 1 plus 3 is 4. All right, take your second input, or your third input, which is 4, divide it by 2, and add 3. 4 divided by 2 is 2, and 2 plus 3 is 5. Now, once you see the pattern, you don't have to keep using the verbal description. So we see a pattern developing here, 3, 4, 5, so we know this is 6, 7, and 8. So now we've represented this function as a table. We could also represent this function as a graph. To do that, let's see, we'll just graph each point. 0, 3 would be right here, 2, 4 right here, 4, 5, 6, 6, 8, 7, and 10, 8. All right. Now, for the range, you're going to simply list your output numbers, which they were 3, 4, 5, and we've got a pattern going here, dot, 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 till you get to 8. Okay, so that represents 3, 4, 5, 6, 7, and 8 is our range. All right. In example 2, Cassie borrowed $175 from her parents to buy a new pair of earbuds. Over the summer, she paid them back with money she made from her summer job at a rate of $25 per week. Create a table and a graph of this situation and then state the domain and range. So when you're creating a table, your top row is always your X or your input. Your bottom row is your Y or your output. Okay. So in the beginning, at week 0, we know that Cassie owed $175. Now, let me go back because I didn't highlight our knowns and our unknowns for this problem. And I think that's a really important skill to get used to doing, is to highlight what do you know and what are you trying to find. So in this problem, we know she borrowed $175 from her parents. And we also know she's going to pay them back at a rate of $25 per week. So that's basically our knowns. Our unknown, or what they're trying to try to find, is they want us to create a table and a graph and then state the domain and range. So those are our mission here. Create a table and a graph, then state the domain and range. So at week 0, we know that she owed $175. After 1 week, she paid them back $25. So now she only owes them $150. Okay. After week 2, she pays another $25, so now she owes $125. Week 3, she would owe $100. Week 4, she would owe $75. Week 5, she would owe $50. Week 6, she would owe $25. And week 7, she would owe $0. Now, when you're creating this graph, we have the number of weeks on our x-axis, and we have our balance remaining on our y-axis. However, this graph is going to need to be scaled by something other than ones, because on our y values, we have our smallest y value is 0, and our largest y value is 175. So I'm going to try to scale this graph by 25s. So now I'm not going to write all of them because I don't really have room. So 25, 50, 75. So this would be 100. 25, 50, 75. This would be 200. So each little tick mark is going to be worth 25 units. And on the x-axis, I'm just going to scale that by ones. Okay. So at week 0, she owed $175. So that would go right there. At week 1, she owed $150. Week 2, $125. Week 3, $100. Week 4, $75. Week 5, $50. Week 6, $25. And week 7, she finally paid them off. Okay, so for our domain, 0, 1, 2, 3, dot, 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 7. And I can use those dots because we have a definite pattern here of increasing by ones. Now, be careful when you list your range. Most, but not all teachers are going to want you to list your range in numerical order with the smallest value going first. So our smallest y value was $0, and then 25, 50, 75, and you can definitely see the pattern going by 25s. So dot, 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 all the way up to 175. So that would be your range. All right, example 3. A function is represented by the graph below. Represent this function as a mapping and then answer the questions. All right, so what do we know? I'll do that. We know we have a function represented in the graph. What do they want us to do? Represent the function as a mapping and then answer the questions. All right, so let's look at our graph. To make the mapping, what I want to do is convert this graph into a table of values. So I'll put X here, Y here. So if I start on the left here, 1, 2, -3, 1, 2, 3, 4, 5, 6, 7. So -3, +7. Then -1, 1, 2, 3, -4. Then 2, 1, 2, 3, 4, 5. 3, 5, 1, 2, 3, 4, 5, 7. And 1, 2, 3, 4, 5, 6, 7. And -2. All right, so those are the values we're going to use to create our mapping. So when you make a mapping, it's two ovals. The input will go first, the output will go second. Remember, your input are your X values or your domain, and your output are your Y values or your range. So what you're just going to do is you're going to list your X values, -3, -1, 2, 5, and 7. Okay. Now, -3 in our table matched up with 7, so you will draw an arrow from -3 to 7. That means when you put in a -3, you get out a 7. All right. -1 mapped up to -4. 2 mapped up to 5. 5 mapped up to 7. Now, we already had a 7, so we just draw an arrow going that way. And 7 mapped up to -2. All right, so there's our mapping. All right, our first question is, if the point 5, 1 is added to the graph, would the relationship still be a function? Why or why not? So if I added 5, 1 to our graph, 1, 2, 3, 4, 5, 1, that would be a point right here, and then I'm going to add it to the table right here. Now, I want you to go back to the very beginning when I defined a function for you. And I wrote something down right here. In a function, the value of X cannot repeat. So if I add a 5, 1 to the function, I want you to notice what just happened. That caused the X to repeat. So would it still be a function? No, because X equals 5 repeated. Okay. All right, so for the domain of the function, we have -3, -1, 2, 5, 7. That's our X values. Now, for your range, remember I said most teachers, not all, but most are going to want you to put your values in numerical order. So I want to start with my smallest range value, which was -4, then -2, then 5, and then 7. Okay. All right, example 4. For each problem below, circle the letter of the representation that is a function and then state the domain and range of the function. So let's highlight in green what they're asking us to do. Circle the letter of the representation that is a function, then state the domain and range. All right, so two things here. All right, so look at problem A. Or the first example, we have two tables, table A and table B. To tell us something's a function in table form, you're going to look at the X values and see if any of them repeat. -2, -1, 0, 1, and 2. None of the X values repeated. Okay, look at table B. -3, -3, 4. Uh-oh. That X value repeated. So this one, not a function. So it said to circle the representation that is a function and then state the domain and range. So our domain would be -2, -1, 0, 1, 2. The range, just a 6. You do not have to list it more than one time because that's the only element of your range. All right. All right, look at example. Our next example, we have two graphs shown, and they want to know which one of the graphs is a function. So when I'm looking at graph A, I notice a problem because this point here would be 1 comma negative 3, and this point here would be 1 comma positive 3. So if you notice, the x value repeated. So this one, not a function. So if we look at the next graph, this would be a function. So the domain of this graph, let me just label these points. Let's just rewrite this as a table here. All right, 1, 2, negative 3, 2, negative 1, negative 2, 1, 3, and 3, 3. All right, so now it's easier to state our domain and range if we represent the graph as a table. So our x values were negative 3, negative 1, positive 1, positive 3. Our range, start with the smallest value, negative 2, then your next smallest value, which is positive 2, and then the 3, you do not have to write more than one time. So just the 3. Now, in our next example, we're going to learn how do you tell if a relationship's a function if all you're given is the graph of that function. So you don't have a table or a mapping. Okay, so in the second part, we're going to talk about something called the vertical line test. The vertical line test is a visual representation or a visual method for determining whether the graph of a relationship is a function. The vertical line test states that a vertical line can intersect the graph of a function at most at one point. If a vertical line can be drawn which intersects the relationship more than once, the relationship is not a function. So in problem A, it says use the vertical line test to determine whether each relationship represents y as a function of x. So in problem A, we have a circle. Okay, and what we're going to do is we're going to draw a vertical line through this circle and see how many times if it intersects. If it intersects more than once, it's not a function. So let's just draw a random vertical line here. And notice it intersected that circle here and here. So if you can draw a vertical line that intersects this graph more than one time, it is not a function. Okay. All right, let's look at our next graph. Here we have a U-shaped graph. Now, let's draw a vertical line here. What if I drew the vertical line right here? Notice it only intersects at one time. Let's say I drew it right there. It only intersects at one time. Maybe I draw it one here. Only intersects at one time. So everywhere I try a vertical line, it only intersects at one time. So this one is a function. Okay. Now, a lot of people get tripped up on problem C because it's a vertical line. How do you do the vertical line test on a vertical line? Well, there's only one place you can do the vertical line test, and that's right on top of the vertical line. So notice your vertical line test intersects this graph way more than one time, an infinite number of times. So this is not a function. All right, now what I'd like you to do is pause the video and try problems D, E, and F on your own. All right, welcome back. Let's see how you did. On problem D, I drew a vertical line and it only intersected one time, so I said that D was a function. All right, problem E. I drew a vertical line. It intersected it 2 times, so not a function. Problem F, we have a horizontal line. If I draw a vertical line, it's only going to touch it one time. So this one was a function. So if necessary, pause the video and correct anything that you might have gotten wrong. If not, that concludes today's lesson on Introduction to Functions and the Vertical Line Test.